NCM Learning Center.
Good morning friends. In this video, we are going to discuss about the small signal analysis of BJT. If you refer these concepts, small signal analysis concepts from any book, this topic is somewhat difficult. But if you refer that video, it will make easier. So, listen this video fully carefully. After that video, you can understand these concepts very clearly and you can solve any type of questions from the small signal analysis concepts. So, we will discuss the basic points of BJT analysis. We know that the BJT mainly used for the AC signal amplifications. For proper AC signal amplifications, DC biasing is required. Already we discussed the various DC biasing methods: fixed bias, voltage divider bias, collector feedback bias methods. All these concepts are discussed in a single videos. The DC biasing maintain the operating point Q point in the midpoint region. Q point means collector current versus collector to emitter voltage VCE. If you not maintain the DC operating point in the middle region, we cannot get the proper output waveform. Proper output waveform means if you not maintain the operating point in the midpoint, you will get some distorted waveform. Sometimes the positive wave may be clipped, sometimes the negative wave may be clipped. If you maintain the operating point in the mid region, you will get the proper sine wave. So, when we analyze the DC biasing, AC signal will be considered as 0. When we analyze small signal analysis, AC analysis, DC will be considered as 0. What is the use of DC biasing? The DC biasing is fully related with the operating point, IC and VC calculations. What is the use of small signal analysis? By the AC analysis, we will calculate the voltage gain, input impedance and output impedance. Okay, this is the basic points. By the basic points, now we know that why the DC biasing is required, why the small signal analysis is required. Now, we will discuss the small signal analysis concepts. The equivalent AC circuit, the BJT equivalent AC circuit is, this is the BJT. Here, the base to emitter is considered as a resistors, and the collector regions is represented as the controlled source, current controlled source, because BJT is equal to current controlled source. FET is equal to field effect transistor is equal to voltage controlled source. This is the equivalent circuit of BJT. We should know, we should remember that. Okay, the base to emitter is represented as a single resistors, or by the collector. In the collector, it acts as a controlled source. Okay. Now, this is base current, this is emitter current. Here it is represented as small values, IB, IE, IC, all small. So, if it is represented small IC, it is a AC collector current. That means small signal analysis collector current. If it is represented as capital IC, it is DC collector current. So, if you refer the DC biasing concepts, all the parameters are represented in capital. Okay. So, small IE means AC emitter current. Capital IE means DC emitter current. Small IB means AC base current. Capital IB means DC base current. This is not the same. IC is not equal to capital IC. IE is not equal to capital IE. Okay. VBE means small value AC base to emitter voltage. Capital VBE means DC base emitter voltage. If you know the relations between the AC parameter and DC parameter, then only the small signal analysis concept is very easier. So now we are going to find the relations between the AC parameter and DC parameter. This conductance for the DC biasing is GM. We know that conductance means inverse of resistance, so current by voltage. For DC biasing, transconductance is GM is equal to IC by VT. IC means collector current, VT means thermal voltage. For BJT and diode, thermal voltage VT is equal to 26 millivolt. Okay, we should remember this formula, or otherwise the justification for this is the basic formula for the transconductance is GM is equal to change of collector current to change of base emitter voltage. So we know that collector current equation IC is equal to I naught e power VB by VT. This is a collector current equation, basic equation. Now find the change of collector current. Differentiate this equation with respect to base emitter voltage. We will get here this is constant. Here e power x. Differentiation of e power x is e power x. So we will get e power this value EBE by VT. If you differentiate this value, we will get 1 by VT. Okay. Now we know that I naught e power VBE by VT is equal to IC. Substitute here, we will get IC by VT. So transconductance GM is equal to IC by VT. If you feel that no need of justification, just remember that the transconductance for DC biasing is GM is equal to IC by VT. For small signal analysis, for AC analysis, the transconductance for a small signal, the variation is very small. So transconductance GM is equal to small IC collector current by small VBE, base emitter voltage. Okay, this is for AC signals. This is for DC signals. Both are equal. Transconductances are same. Both are equal value. So equate this, we will get small IC by VBE is equal to capital IC by VT. Okay, now small IC is equal to capital IC into small VBE by VT, capital VT. Small VBE means AC signals based emitter voltage. Here VT means thermal voltage. The capital IC means DC biasing collector current, DC current. Small IC means AC current. So remember that small VBE is not equal to VBE, is not equal to 0.7. Okay. Now the relations between the small IB and capital IB. We know that beta is equal to capital IC by capital IB, or otherwise small IC by small IB. Beta is same for both AC and DC current gain. So we know that IC is equal to beta into IB. Here substitute these values in this equation. We will get, instead of IB we write beta IB is equal to capital IC into VB by VT. So small IB is equal to capital IC into VB by beta VT. Now IC by beta, we write IC by beta is equal to IB. Okay, this is the small IB and capital IB relations. Okay, now from the equivalent circuits, what is RY? Resistance. RY is equal to, by the AC circuits, the resistance RY is equal to voltage VBE by IB. Because voltage across the resistor is VBE, current flow through the resistor is IB. Okay. Now substitute this IB values in this equation, we will get VBE by IC by IB value. Instead of IB, we write IC into VBE by beta VT. Now VB we cancelled, we will get beta VT by IC, or otherwise VT by IB. Resistance is equal to voltage by current. So VT for DC, VT thermal voltage VT by IB. Okay, this is the relations between the AC current and DC parameters. We should know these parameters. If you know this equation, the relations between the AC and DC parameters, then only we can analyze the small signals. Okay, if you know these concepts, you can solve these small signal problems. Now we will solve this problem. If you solve this problem, you can clearly understand. So this first question, this question is asked in GATE 17 EC examinations. The objective of this question is we got to find the midpoint voltage gain. Voltage gain calculation means definitely it's a small signal analysis concept. Here thermal voltage is given 25 millivolt. VB, this is DC parameter. Base emitter voltage is given 0.7. we go to assume that here base current is negligible. DC analysis. For the DC analysis, base current is 0. So DC current value IB, capital IB is equal to 0, not small IB. Okay, capital I is equal to capital IC. Okay, so the first step, we have to redraw the circuit into a AC circuits. When we analyze the small signals, the DC voltage, the DC value will be considered as 0, grounded. It is a grounded. Then the capacitor acts as short. The capacitor acts as short circuit. When we analyze the AC signals, the capacitor acts as short circuit. When we analyze the DC circuit, DC analysis biasings, the capacitor acts as open. Okay, remember that. Now, what is the equivalent circuit of BJT? This is the equivalent circuit of BJT. This BJT. Base, emitter, collector. In the base emitter, here resistors. In the collector to emitter, it is a current controlled source. IC, small IC. This is the equivalent of this BJT. Now, in the emitter side, in the given circuits, in the emitter side, RE is connected between emitter to ground. Okay, this is ground. Okay, so listen that in the emitter side, RE resistance is connected between emitter to ground. So we have to connect here. Emitter to ground, 2 kilo ohm resistance connected. Now the capacitors. Capacitor is connected parallel with the RE. Here capacitor acts as short circuits for the AC analysis. So it is short circuits. The capacitor acts as short. Okay, now the emitter portion is over. In the base region, base to ground, the R2 resistance is connected. Base to ground, this is ground. Base to ground, R2 resistance, 47 k ohm is connected. Okay, the 47 ohm is connected. Then this base to VCC. VCC means ground. Listen that base to ground. 73 kilo ohm is resistance is connected. This is the base. This is ground. Base to ground. 73 kilo ohm is connected. Okay. This DC voltage will be considered as ground, 0 volt. So base to ground, 73 kilo ohm is connected. Then the capacitor acts as short circuits. So VI is connected. Now the base side is over. Then collector side. The collector side, the capacitor acts as short circuits. So collector to ground, 8 kilo ohms RL is connected. Collector to ground, 8 kilo ohms are connected. Then the collector to ground, this is ground. So collector to ground, 2 kilo ohms are connected. Collector to ground, 2 kilo ohms are connected. Okay, V0 is in parallel to 8 kilo ohms. This is the equivalent circuit of these circuits, this given circuits. At the emitter side, here, at the emitter side, 2 kilo ohm, this is short circuit. Short circuit means 0 ohm. 0 ohm are contained parallel. This is 0 ohm. Okay, short means 0. Are contained parallel. What is the value of equivalent value? Equivalent value RE1. If it is 2 resistors are parallel, we will get equivalent is R1 R2 by R1 plus R2. We will get 0 ohm. Okay, the total resistance for this emitter side is 0 ohm. At base side, 47 kilo ohm and 73 kilo ohms are contained parallel. So what will get equivalent value? RB1 is equal to, will get 28.59 kilo ohms. Similarly, at collector side, the 8 kilo ohms or 2 kilo ohms are contained parallel. So we'll get RC1 is equal to 1.6 kilo ohm. Now the 73 kilo ohm and 47 kilo ohms is equal to 28.59. This is equal to 0. In the collector side equal to 1.6 kilo ohm. So we may rewrite this circuit diagram like that. Okay. Now apply Kirchhoff's voltage law, mesh analysis, find the voltage, input voltage, output voltage, then voltage gain. V0 calculations. Output voltage. So let us take this equation, this current is Ix. So we will get V0 is equal to Ix into 1.6 kilo. This is open. V0 load side is open. Okay. So V0 is equal to Ix into 1.6 kilo ohm. Just apply the Kirchhoff's current law at this junction. You will get. So incoming current is 0. Outgoing currents are Ix plus Ic. So we will get Ix equal to minus Ic. This is open. Okay. This load V0 is open. So substitute here, we will get V0 is equal to minus Ic into 1.6 into 3. Now output calculation is over. Okay, Ic is equal to beta Ib, Ic, small Ic, trans conductance into VBE. Already we know that formula, trans conductance formula. We may represent. Now the calculation of input voltage. Just apply the Kirchhoff's voltage law at this loop, at this node, at this loop. Vi is equal to VBE, small VBE. You may write VBE is equal to IB into R by. So the voltage gain V0 by Vin is equal to, for V0 formula we write, instead of IC we may write GMVBE. So I minus GMVBE into 1.6 into 10 power 3 divided by here VBE. So VBE cancel, we will get minus GM into 1.6 into 10 power 3. Okay. Now we know that the transconductance GM is equal to IC by VT. Here IC means capital DC current, VT means thermal voltage. Thermal voltage is already given 25 millivolt. We can find the DC parameter IC. Okay, substitute these values in the voltage gain, we will get this equation. Let us take this equation as 1. Now the calculation of IC is very important. So when we analyze small signal analysis, first we need the DC biasing analysis also. Okay. Refer this voltage divider bias concepts. This is the given circuits. Okay. We go to find the collector current. The DC analysis, already we know that the AC signal will be considered as 0. The capacitor factor is open. Okay, this is open, this is open. Now find this voltage, this base voltage, this voltage divider. Okay, so voltage divider formula, we know that voltage divider formula. Here this point, in this point, VB is equal to total voltage VCC into this branch resistance R2 into sum of the resistance R1 plus R2, because it's open. Okay. So what is the VB? Substitute here, we will get 4.7 voltage. Now find the RB, R0 R2 are parallel. Thevenin's resistance. Okay. So substitute these values, 47 kilo ohms and 73 kilo ohms. Here we will get 28.59 kilo ohms. Already we find. Okay. Now the equivalent circuit will become like this. Here this is 4.7 voltage V base voltage. This is RB. This is load. Now the circuit analysis is very easy as compared to voltage divider bias. Just apply use voltage line in this junction. Already given base current is 0. Base current IV value is 0. So this drop is 0. So apply this voltage line in this junction, we can find the IE value. If IB is equal to 0, IE is equal to IC. Substitute here 4.7 is equal to 0.7 plus IE into 2 into 10 power 3. Because this drop is 0. Now we know that IE is equal to IC because IB is equal to 0. So IC is equal to, from this equation we will get 2 milliamps. Capital collector current, DC current is over. Now substitute these values in the equation number 1, voltage gain equation, we can get the voltage gain. So V0 by VA is equal to, here this values minus IC. IC means 2 into 10 power 3. This is resistance, load resistance 1.6 into 10 power 3 VT. VT value is given 25 millivolt. So simplify this equation, we will get 128. This is the minus 128. Okay, minus 128. This is the voltage gain. Magnitude for this voltage gain is 128. This is the answers for these questions. Now do it yourself. Remember that if you practice this small signal analysis concept, then only the concept will be easy. If you not practice, it will be easy forget. So just practice these questions. This question is asked in GATE 2020 examination, EC examinations. we go to find the voltage gain. The second questions. The second question is from gate 14 triple E and third question is from gate 14 EC. Just pause this video, note these questions and solve these questions. Okay. The answer for the question is, for the first question answer is minus 89.4. For the second question is 100. Because here the magnitude only given. So if it is magnitude means it will be positive value. Voltage gain means the value will be negative. So for the third question answer is minus 237.76. Okay, good, thank you. Visit our website www.ncmlearningcenter.com. You can get the video materials for GATE, IES, ISRO and other competitive examinations. Then PDF materials, PDF book materials prepared for NCM Learning Center. If you use this material, definitely you can get the good marks in the competitive examinations. Then you can get the test series. Join our WhatsApp group, NCM Learning Center WhatsApp group. That link is attached in the description box of the video. Join in our group. If you have any doubts related to the discussion, just post in the WhatsApp group. You can get the solutions. Okay, good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.